Hello, good day everyone. So welcome sa another module sa ating Math 171, Calculus 1, Differential Calculus. So for today, ang i-discuss natin is Module 11 or the application of the derivative. So actually, ito yung first topic natin. We're in application ng derivative or differentiation, which is optimization problem. So here, yung mga napag-aralan natin from previous module, both Calculus and MMW is i-apply natin dito. But before we discuss kung ano yung mga topics and concepts na nandito sa optimization problems, let us first identify the lesson objectives of this module. First is to recall and state the basic formulas of solid mensuration. So actually, the topic under your solid mensuration in the subject, in-skip natin, but I suggest balikan nyo lang, i-scan nyo lang siya. But anyway, i-discuss naman natin briefly yung ating mga formulas pagdating sa solid mensuration bago tayo mag-start solving optimization problems. Also, another objective is for us to solve problems dealing with maximum and minimum values. From previous modules, we encountered maxima and minima or ito ang maximum and minimum values. So i-apply din natin siya in solving optimization problems. So before we recall and state the basic formulas ng solid mensuration, ano nga ba yung optimization problems? When we say optimization problems, these are problems wherein we optimize or kinukuha natin yung maximum and minimum value of a variable or a quantity. So usually, ang may encounter natin dito later pag nag-discuss tayo ng problems is yung mga values ng, for example, square or rectangle. For example, rectangle, usually ang mga tanong, what will be the dimension of sides given that the area of the rectangle will be maximized or minimized. So mga ganun yung approach ng questions pagdating sa optimization problems. So magsasolve tayo ng problems kagaya nung nabanggit ko para mas maintindihan natin yung optimization problems. So now let's recall those formulas na yung iba nabanggit na natin dito from our past modules, previous modules. So we have here the triangles and then right triangle and equilateral triangle. So ito ay nabanggit na natin. We have here the perimeter, simply the sum of the sides of a triangle, area, 1/2 base times height, and then different formulas for area depende sa given. So binigay din dito yung area of a triangle with two given sides and one angle. Binanggit din dito yung cosine and sine law. And for right triangle, we just used Pythagorean theorem and basic trigonometric functions, sine, cosine, and tangent. And then for equilateral triangle, meron tayong formula ng h or height ng ating triangle. And then area, which is based din sa h na binigay sa atin dito. So tatandaan nyo lang yung formulas na ito. So we also have here the rectangle, circle, and trapezoid. Babalikan lang din natin. In rectangle, we have formula for perimeter, the sum of the twice of length and width, or 2 times L plus W. And then when it comes to area ng rectangle, it's just the product of the length and its width. For circle, we have the circumference area, a circumference and area, wherein circumference is just 2 pi r or pi d, and then area is pi r squared or pi over 4d squared. Okay. And for trapezoid, we have a 1/2 upper base and then the sum of upper and lower base multiplied by height. So yun yung formula ng area natin. Also, we have here the circular sector. So pag circular sector, it is somehow parang portion lang siya ng circle. Okay, so of course, if portion lang siya ng circle, meron din angle yan, central angle, which is theta. Wherein dapat naka-radian. Okay? And we have S or the arc length ng ating sector. We have the radius ng ating circle as a whole. So when it comes to formula niya sa area, it's just 1/2 r squared times theta, wherein theta is in radians. If wala namang sa degree yung theta natin na ito, therefore i-convert pa natin. And then for arc length, the formula lang niya is theta r, wherein theta is naka-radian. So we also have here solids. So actually, there are a lot of solid or solids na meron tayo when it comes to solid mensuration at topic. But here, these three are the most common na ma-encounter natin sa optimization problems. The cylinder, of course, ang face niya is dalawang circle, magkabilang dulo, and of course, meron siyang height na h. Uh, So, ang surface area niya or lateral surface area niya is 2 pi RH wherein ito yung gilid ng ating cylinder. And for the volume, it's just the area of one face multiplied by its height. And for circular cone, ang kanyang lateral surface area is pi RL wherein L is the slant height. Hindi yan class yung upright height ha. Slant height yung patagilid. Yung nakaslant itong part na to. And then yung L is nasusolve naman by using the Pythagorean theorem using the value of h and then the radius. For its volume, circular cone, meron ka 1/3 pi r squared times height. And lastly, for a sphere, you could get the value of its surface area by using the formula S is equal to 4 pi r squared. And for its volume, it's 4/3 pi r cubed. Okay, so itong tatlo na to, yung pinaka may encounter natin later sa ating problems. So, kumbaga, pag hindi nyo alam yung formulas natin sa mga shapes and solids natin, hindi natin masosolve yung ating optimization problems. So for us to be able to solve optimization problems in easier way, we have here guidelines and steps to solve them. So gaya ng sabi ko, meron tayong steps. We have 5 steps. So we could use this para makapag-solve ng optimization problems when it comes to maximum and minimum values. So first, we have reading the problem carefully until it is clearly understood. So of course, you have to understand ano yung sinasabi ng message natin. Sometimes there are givens or na meron talagang value but hindi mo siya makikita sa problem unless you understand each statements provided sa problem. Also, ask yourself what is the known quantities and what are the unknown. Okay? So tingnan nyo lang kung may numerical value na given and at the same time, baka read between the lines ba, parang ganun. Intindihin nyo mabuti. And for the unknown, tingnan nyo kung ano yung tinatanong ni problem. And even the condition na pinrovide ng ating questions. Next is draw a figure whenever necessary and denote the variable quantities by X, Y, Z, or other letters. Okay? So dito, drawing natin yung figure nung naka-state sa problem para guide natin, para mas accurate yung solution ng sagot natin. So gagamit tayo ng variables, mga letters, para lagyan ng label ng ating illustration para alam natin ano yung walang value, ano yung meron. Next is identify the quantity to be maximized or minimized and express it in other variable quantities. If possible, accept this quantity in terms of one independent variable. So here in step 3, we identify ano nga ba yung sinasabi ng problem na i-maximize or minimize. So pagaya ng sabi ko kanina, yung example natin na rectangle. So pag may tanong kayo, meron tanong sa atin na what is the size or what will be the value of sides of a rectangle that given that the area of the rectangle will be maximized. So ang sinasabing i-maximize natin is yung area ng rectangle. Okay? So titingnan nyo kung ano yung sinasabi na problem na i-maximize or i-minimize. And then after you construct equation, ating working equation, make sure na yung equation na yan is naka in terms of one variable na lang. So later papakita natin yung sinasabi natin sa step 3. For the first steps, find the first derivative of the function and equate the derivative to 0. So from our previous module, we know na yung first derivative natin is just the slope of the line, just the slope of a curve or a function at a specific point. Wherein, pag nasa maximum or minimum point ka, ang slope natin dun ay 0. That's why, pag kinuha natin yung derivative ng ating equation, ini-equate natin siya sa 0. Parang ano yan, parang kasi ang kailangan nating value is yung nasa taas o nasa baba. That's why ini-equate natin sa 0. Okay? Dinedenote niya, pag in-equate natin sa 0, yung values na makukuha natin is na doon sa maximum or minimum point. So, sana clear yung bakit tayo nag-equate sa 0. And lastly, so for the values and variable and check whether they maximize or minimize the given quantity. So these are the 5 steps para ma-solve natin ang ating maximum and minimum problems or yung optimization problem. So I think ready na tayo para mag-solve ng ating problems para mas mag-gets natin yung mga sinasabi ko kanina. So let's proceed to our examples. So now let's proceed to our first example in optimization problems. First, we have here expressing the diameter of a spherical ball as a function of its volume. Okay? So para ma-solve natin yan, gamitin natin guide yung ating guidelines kanina. Gamitin natin yung steps in solving maximum and minimum problems. Yung 5. Okay? So first, sabi, identify all quantities given or quantities to be determined. Tapos sketch daw natin. So first, ang sabi, identify what are the unknowns, what are the given quantities, and ano yung given condition. So yung unknown sa atin is yung diameter tapos as a function of its volume, yun yung unknown. So diameter, yun yung unknown. So diameter yung nawawala. Ayan, as a function of volume. And then given quantities, wala namang given quantities. Pero sinabi sa atin na spherical ball. Okay? So ano nga ba yung volume ng spherical ball? So pag sinabi natin volume ng spherical ball, yan ay sphere lang. So yan ay 4/3 pi r squared. Okay? Or in terms of diameter, pwede din yan na yan, pwede natin i-rewrite na pi d raised to 3 over 6. So pwede nyo namang i-analyze to bakit naging ganyan. Kasi may r ka dito, tapos yung d. Yung r kasi is ita times 2 mo lang. So kaya naging pi d raised to 3 over 6. Anyway, yan yung given na isa natin. What are the given conditions? So, anong binigay na conditions sa atin? Wala naman. Wala rin nabanggit dito if maximum or minimum. So, let's just solve the problem. So, next is draw the figure if necessary. So, hindi naman na ganun kakailangan i-drawing yung ating figure. So, kahit wag na. Okay? And then, third is which quantity to be maximized. So, wala naman sinabi na i-maximize or even i-minimize. Okay? And the next is the derivative. Let's see kung meron ba tayo the derivative. But since wala naman maximum and minimum value na nire-require sa ating condition, therefore, hindi siya kailangan i-derivative. Okay, so anyway, meron tayong volume dito. Volume ng sphere is equal to pi d cube over 6. So, ang hinihingi lang sa atin, diameter na naka-function of its volume. So, meaning, cross-multiply lang natin yan. You will have a pi d or pwede ko nang iwanan yung d dito sa may kaliwa. So magkakaroon tayo ng 6v ng sphere over pi. But since naka-cube pa yung d natin, get the cube root of both sides, we will have d is equal to 6 times volume of the sphere over pi. Tapos cube root. Okay, so therefore, ito na agad yung sagot natin. Yan. Simple pa siya. So wala naman ni-require sa ating i-maximize and minimize. Therefore, hindi pa tayo nagde-derivative. Okay? So for our second example, we have here the area of a rectangle is 6 square inches daw, hindi ba? Then the length of the other side is 6 over x. And the perimeter is, so ngayon, ganun ulit. Sundin natin yung steps natin. So first is identify natin yung knowns and unknowns. So we have here area of the rectangle, which is 6 square inches. We have the side, yung isang side na rectangle. Sabihin natin yung side ng rectangle is x and y. Sides of rectangle. Okay, so next is i-drawing daw yung figure. So i-drawing lang natin, we have here a rectangle. So we have here x tapos y. So ngayon, yung unknown natin, nakalimutan natin. Ang unknown natin is yung perimeter. Okay. So lagay natin, area of a rectangle is equal sa x times y lang, hindi ba? So binigyan tayo ng area ng rectangle na 6. Ayan ay x times y. So y, divide natin both sides ng x, magkakaroon ka ng 6 over x. So that's why meron ka ditong 6 over x. Ayan, sa given pa lang. Okay, doon lang galing yun. And then kailangan natin is perimeter. Ano ang formula ng perimeter pagdating sa rectangle? 2x plus 2y. So gawin natin yan. P is equal to, meron ba tayong value ng x? So retain lang natin yung x plus 2 times 6 over x, which is yun yung y. So P is equal to 2x plus 12 over x. So simplify lang natin, P is equal to, factor out po yung 2, you will have x plus 6 over x. Therefore, it is our final answer. Sir, bakit ini-skip natin yung ibang steps? Hindi tayo nag-derivative. As you can see, just like the previous example, wala namang binanggit na values na kailangan natin i-maximize or minimize. So, differentiation is unnecessary for our solution. Okay, so ganyan lang natin i-solve yung example number 2. Ayan. So we have your example number 3. The sum of the two numbers is 100. Find the minimum value of the sum of their cubes. So as you can see, nagkaroon na tayo ng term na minimum. So therefore, magkakaroon tayo ng differentiation later sa ating solution. Okay, first is what is the unknown? Kailangan natin ng minimum value. Find the minimum value of their sum. So yung sum na minimum ang kailangan natin. So S min. Sabihin natin yan yung minimum sum of two numbers. cube. Lagyan na lang pag naka-cube. Okay? So, ano yung given quantities? Meron tayong sum of two numbers. Sum of two numbers yan. Tapos, sabihin natin yung x is the first number, and then y is the second number. So, gamitin natin yung x and y. X plus y is equal to 100. That's our first equation. So, tingnan natin kung may magagamit tayo dyan. But, meron pa bang ibang binigay? So, parang wala na. Okay? Pero sabi dito, find the minimum value of their sum of their cube. So, yung S na lang yung gamitin natin na sum. So, S is equal to x cube plus y cube. So, kailangan natin tong i-minimize. Di ba? So, may kailangan ba tayo i-drawing? Wala naman. At nag-set na tayo ng variables sa ating givens. Okay na yun. So step 3, identify natin yung i-minimize or maximize. But sabi nga natin yun yung value ng sum of their cubes. Okay? Then in terms of one variable na ba itong equation natin na to? Hindi pa. So kaya gagamitin natin itong formula na to. Yung equation na may check na yun yung ginawa natin. So yung x plus y is equal to 100. Pwede natin siyang i-rewrite na x is equal to 100 minus y. So, isa-substitute natin ito, yung x na yun dito sa ating S equation. So, meron kang 100 minus y cube plus y cube. So, as you can see, meron ka ng isang uniform na variable sa ating equation na yan. Di ba? Y na lang siya. So, since meron ka ng ganyang equation, we could just proceed to differentiation. So, derivative of S in terms of y, kasi y na lang yung terms natin, is equal to, so, general power rule. So, 3, tapos 100 minus y. 3 minus 1 is 2. Huwag kalimutan yung derivative sa loob. Meron kang negative 1. Bakit negative 1? Derivative of y, derivative of negative y in terms of y is negative 1. Sir, hindi ba yan y prime? Hindi yan y prime kasi in terms of y ang ina-analyze natin. Kung sana in terms of x, magkaka-y prime ka. Well, anyway, hindi siya y prime. Negative 1 siya talaga. So, the derivative of y cubed is 3y squared. So now, anong sabi kanina para malaman yung maximum minimum value, i-equate daw natin yung derivative or yung first derivative sa 0. Okay? So, ano na nga pwede natin gawin dyan? Pwede natin simplify muna yung mga values natin. So, magkakaroon ka negative 3, 100 minus y squared. Lipat ko sa kabilang side yung 3y squared. Divide both sides by negative 3. We will have 100 minus y squared is equal to y squared. So, dali natin dito. We will have, yung 100 minus y, i-simplify na natin yun ay 10,000 minus 200 y plus y squared is equal to y squared. So, lipat natin sa kabila yung y. Cancel out sila, magiging 0. We will have 200y. Lipat natin sa kabila yung 10,000. Y is equal to 50. So, paano naging 50 yun? Divide both sides by 200. Okay? O kaya, multiply 1/20 both sides. So, magkakaroon ka ng y is equal to 50. So, ito na ba yung sagot? Hindi pa, kasi y value pa lang. Para makuha natin yung x natin, gamitin na lang natin yung equation na to. So, x is equal to 100 minus yung y na nasolve na 50. Therefore, x is equal to 50 din. So, para malaman yung minimum value ng sum of their cubes, balik tayo dun sa formula or sa equation natin kanina. So, S is equal to, yung X natin ay 50, tapos cube, plus yung Y natin which is 50 din. Cube is equal to 50 cube plus 50 cube equal siya sa 250,000. So, therefore, this is the minimum value of the sum of the squares, of the cube of the two numbers. So, yun na yung final answer natin. Yung 250,000. So, we also have here example number 4. So, para mas magets natin yung paggamit ng steps kanina sa kung paano mag-solve ng maximum and minimum problems, no? Let's have this example 4. Find the dimensions of a rectangle with perimeter 100 meters and whose area is as large as possible. So, balikan natin yung steps natin sa pag-solve ng maximum and minimum values pagdating sa optimization problems. So, ano nga ba yung given? So, binigyan tayo ng perimeter. So, given, perimeter ng ating rectangle is 100. Tapos, sinabi pa dito, whose area is as large as possible. Meaning, yung area daw is maximum. Mama-maximize natin as large as possible kasi ang sabi. So, area is maximum. Okay, so ayan, magkaka-idea ka na kung ano yung i-maximize natin na formula later or ano yung i-derivative natin na equation. So next is determine the unknown. Ang unknown is yung dimension ng rectangle. So po pwede yan maging square din. So meaning equal ang dimension na dalawa. So sabihin na lang natin na x and y sides of the rectangle. Okay? So, na-identify na natin yung known, na-identify na natin yung unknown, na-identify na rin natin yung condition. Next is drawing natin yung figure. So, para mas malinaw yung ating solution. So, we have here a rectangle wherein ito yung x, ito yung y. So, by formula, yung perimeter natin is, sa rectangle ay 2L plus 2W. Or yung L is yung x plus 2W. Ayan. Eh, yung perimeter binigay sa atin yan ay 100. So, meron kang 2x. Hindi ko napalitan tong W ng y. Ayan. Since meron kang 2, tapos divisible by 2 rin yung 100, pwede natin i-simplify yan. Na x plus y is equal to 50. Ayan. So, ito na yung isa nating equation. And then another, pwede natin gamitin din yung formula ng area pagdating sa rectangle, which is length times width or x times y. Okay, now meron na tayong drawing. Meron na rin tayong quantity na i-maximize, which is yung area. Gawa na tayo ng ating working equation. So since i-maximize nga yung A, di gamitin natin tong formula ng area. But as you can see, yung variable natin is x saka y. Sir, bakit ba naging variable yung dalawa na yan? So as you can see, pag nagbago yung x, nag-vary, magbabago din yung y natin. Nakasunod siya kay x. Okay, so hindi sila constant, kaya ganun. Ade, ang pwede natin gawin dito is, in terms of one term natin si A. Paano natin gagawin yun? We have here another equation, yung x plus y is equal to 50. I-derive lang natin. It's either y or x yung ihiwalay natin. Okay lang naman. O sabihin natin x yung ihiwalay natin. So magkakaroon ka ng 50 minus y. Now you have equation number 1. Substitute natin yung x dun sa sa equation na to. You have a is equal to 50 minus y times yung w natin or yung y. Simplify, a is equal to 50y minus y squared. Now, let's proceed to our differentiation. We have dA in terms of y. Is equal to derivative of 50y is just 50 minus 2y. Since maximum and minimum, ang kino-consider natin dito, i-equate natin siya sa 0 dahil nasa maximum or minimum point. So, transpose yung isang value sa kabilang side na equation, we will have 2y is equal to 50. So, divide both sides by 2. We will have y is equal to 25. And then for x, gamitin na lang natin yung equation number 1. So 50 minus 25, x is equal to 25. So as you can see, yung x natin sa y is equal pala. Therefore, na-equal sa 25 meters. So lagyan natin ng m yan. So therefore, yung rectangle natin is square pala siya. Kasi equal yung sides. Okay, another example is find the area of the largest rectangle that can be inscribed in a given circle. Pag sinabi nating inscribe, gaano kalaki ba yung maipapasok natin sa isang circle? Okay? Okay, yung steps ulit natin, balikan natin. Ano muna yung given natin sa problem? So given dyan is parang values, di ba? So unknown, ano yung unknown? Area, yung tinatanong. Yung condition, ano yung condition? Area daw na pinakamalaki. O meaning, area max to be inscribed in a circle. Okay? So next step natin, i-drawing lang natin na mabilis yung circle. So we have here the illustration ng ating figure. We have here the figure na yung rectangle na sa loob ng given circle. Okay. Anong next step natin? After nating i-draw, nalagyan na rin natin ng variables, x and y. Let's proceed to our identification kung ano yung i-maximize. Well, in this case, ang i-maximize natin is yung ating area. So mag-establish na tayo ng ating working equation. So ngayon, A, ang i-maximize class is yung area ng rectangle, hindi area ng circle. Okay, so area ng rectangle is equal sa x times y. So yun lang naman yung given. Next step natin, so nakalimutan natin, meron pa yung diagonal, hindi ba? Wherein ito, yan yung center of the circle din. And at the same time, yung kalahati ng diagonal na yan, ito yung R, tapos ito yung R din. Okay? So ano kaya ang pwede natin gawin? So we have here a triangle na mapo-form, hindi ba? Wherein ito ay 2R dahil pag-a-add din lang natin yung dalawang R, which is the radius, and then we have X and then Y. So if we will proceed to Pythagorean theorem, so we will have 2R squared is equal to X squared plus Y squared. So simplify lang natin, 4R squared is equal to X squared plus Y squared. Okay. So anong next step nating pwedeng gawin? So kailangan kasi natin yung area na to, yung formula na yan, is maging isa lang yung term na nandito sa side. Maging isa lang yung term na variable. Kung sana is constant yung x, eh hindi siya constant. Sana okay na yung equation na yan. Or kahit yung y sana ang constant. Variable kasi yan. Dahil pag gumalaw yung x, nag-iba yung value ng x, gagalaw din yung value ng y natin. Well, anyway, meron tayong na form na isa pang equation, hindi ba? So what if ganito yung gawin natin? I-edit, i-transpose natin, i-derive natin yung ating equation na to. So sabihin natin, ilabas natin yung x. Yung y squared, lipat natin sa kaliwa. So magkakaroon ka ng x. X is equal to square root of 4r squared minus y squared. Ayan. So i-plug in natin itong equation 1 sa ating equation 2. So area ng rectangle is equal to yung x natin is square root of 4r squared minus y squared times y. So as you can see here, yung r kasi class is a constant value when it comes to this problem. Bakit siya naging constant? Kahit magbago pa yung x and y na yan, hindi magbabago yung length ng radius ng circle natin. So that's why yan ay constant. Aside from that, meron na tayong y. Isa na lang yung variable natin. So simplify lang natin. I-rewrite lang natin na mas maayos. Yan ay y. Square root of 4r squared minus y squared. So let's proceed to differentiation. So derivative of a, yan ay yung area ng rectangle in terms of y is equal to, so we have here two terms, two expression. Isang algebraic, isang radical expression. Ang gawin natin, mag-product rule tayo. So y ay u, yung u na y times derivative ng b, since square root yan, so may 2 ka sa denominator, i-write mo lang yung radical sign, minus y squared. Kunin niyo yung derivative ng nasa loob na radical sign, which is 8r minus, 8r tuloy. Constant nga pala ito, so 0 na to. 0 na yan pag dinerivative. So meron kang negative y squared, yan ay negative 2y. Plus, square root of 4r squared minus y squared times 1, derivative ng y. Okay, simplify. Simplify lang natin yung nakuha nating value. We have dA over dy is equal to, since meron ka dyan 2, meron ka sa baba, negative 1 na lang yan. Negative y, o negative 1 y squared kasi dalawa yung y natin. Over square root of 4r squared minus y squared plus square root of 4r squared minus y squared. So simplify lang natin. So kunin natin yung ating LCD. So yan ay square root of 4r squared minus y squared negative y squared plus 4r squared minus y squared. Ayan. So ngayon, equate natin sa 0 since maximum ang kino-consider natin dito. So pag kinross multiply natin, ang matitira na lang is negative y squared plus 4r squared minus y squared is equal to 0. So ngayon, pag samahin natin yung y squared na tong dalawa, yung negative, tapos i-transpose natin sa kabilang side ng equation. So you will have a square root of 2y squared is equal to 4r squared. So ang gagawin natin, divide both sides by 2. We will have y squared is equal to 2r squared. Get the square root of both sides. We will have y is equal to square root of square root of 2 times r. So ito na yung y value natin. But since hindi naman y lang yung hinahanap, kunin natin yung x. So x. So x is equal to, gamitin na lang natin yung equation number 1. Ano? So square root of yung 4r squared minus yung y squared natin is square root of 2r squared. Yan. Simplify, square root of 4r squared minus 2r squared. So x is equal to square root of 2r squared or square root of 2r. Okay, so equal na naman yung x and y natin. So therefore, area is equal to x times y is equal to square root of 2r times square root of 2r. Ang ating area, largest area ng rectangle natin is 2r squared square units. So ito yung ating final answer. Okay, so meron daw tayo dito box, tapos pinapahanap sa find the volume of the largest box that can be made in this way. So first, sundin lang ulit natin yung guidelines natin. Ano? So first, identify natin yung givens and then yung unknowns natin. So binigyan tayo ng dimension ng isang cardboard. So sabihin natin, ito yung ating cardboard and then yung ating cardboard is gugupitin daw in equal squares out of the corners. Kumbaga, tatanggalan natin ang portion sa apat na corner. And then iset natin na x yan lahat. Since square kasi yan, so x yung dimension niya, both length and width. Itong natitira sa gitna, ito ay 9 minus x, ito ay 9 minus 2x, ito ay 9 minus 2x, ito din is 9 minus 2x. Itong nasa baba is 9 minus 2x din. So yun yung given sa atin, yung 9. Tapos ano yung unknown? Yung volume. Yung maximum volume or largest volume na box na pwedeng magawa considering ganito yung setup natin. And then, dinrawing na natin yung ating illustration, yung ating problem. So, i-drawing lang din natin yung box na pwedeng magawa. So, meron ka diyang possible na box. Magiging ganito siya. So, itong box natin na to is hindi siya accurate. Okay, so, for representation lang class. So, itong nasa baba, ang size nito is 2 minus 2x. Ayan, part na yan. And then, yung nandito sa gilid, ang dimension is 9 minus 2x din. And then yung height is x. So mukha lang hindi x yan. So masyadong malaki yung height na na-drawing natin. Well, anyway, for representation lang naman. So since volume ang pinapahanap sa atin, maximum volume, mag-set up tayo ng formula or equation based sa volume. So ano bang formula ng volume pagdating sa isang box or cube? So di ba yung sa isang box is masosolve yung volume by simply multiplying its width, its length, and its height. Well, in this case, tingin tayo sa figure natin, yung volume natin, makukompute natin yung sa width, ano yung width niya? 9 minus 2x. Tapos i-multiply natin yung length, which is 9 minus 2x din. When it comes to its height, ang value niya is x lang din. So ngayon, meron na tayong equation wherein ang variable is uniform, meaning pare-parehas. So ngayon, simplify lang natin para mas madali siyang i-differentiate later. Paano natin i-simplify? So basic algebra lang, distribution, FOIL method. Yung paborito nating FOIL method. So 9 times 9 is 81 minus 18x. So negative 18x plus 4x squared. So huwag niyo kalimutan yung naiiwan na x. So distribute natin, negative 81 times 8. 81 times x is 81x minus yung 18 minus 18 is 36x. Pero may x pa sa labas kaya magiging x squared dyan. Plus 4x cubed. So meron na tayong equation na pwede nating gamitin. Since maximum volume nga ang pinapahanap sa atin, i-differentiate natin yung volume in terms of x. So gawin natin yan, magiging 81 ito. Ito ay 72x plus 12x squared. Ngayon, since maximum value, i-equate natin yan sa 0. So ngayon, kunin natin yung derivative nung nagawa natin na working equation. Ano? So derivative of 81x is just 81 minus 72x plus 12x squared. Then since maximum value ang hinahanap natin, we equate this equation into 0. Ngayon, lahat ng term natin, 81, 72, and 12 are all divisible by 3. Therefore, pwede natin i-simplify yan. Pwede natin gawin, yan ay 27 minus 24x plus 4x squared. Or i-rewrite ko lang ng 4x squared minus 24x plus 27 is equal to 0. So actually, pwede kayong gumamit dito ng quadratic formula. Since quadratic equation naman yan. So gamit tayo ng quadratic formula para ma-extract yung ating roots or yung x values. Pero kung gagamit naman tayo ng factorization, meaning if-factor natin yung ating given equation, yan ay magiging 2x minus 3 times 2x minus 9 is equal to 0. Pero try nyo rin yung quadratic equation, yung quadratic formula para makuha yung roots. Well, anyway, meron tayong 2x minus 3 is equal to 0, wherein x is equal to 3 over 2 or 1.5. Yung isa naman is 2x minus 9 is equal to 0. So x is equal to 9 over 2 or 4.5. Ngayon may dalawa tayong value ng x. So itingnan natin parehas. Hindi tayo pipili dito sa ano natin, sa nakuhang x value. No? Yung isa kasi is x is equal to 1.5 inches. Yung isa is 4.5 inches. So first, gawin natin, gamitin natin yung x is equal to 1.5 inches. Now, so v is equal to, so gamitin lang natin itong equation na to, equal to 81 times 1.5 minus 36 times 1.5 squared plus 4, 1.5 cube. So, ang volume nating makukuha dyan ay 54 cubic inches. O de, okay yan, meron tayong volume na nakuha. What if yung isa naman yung gamitin natin na x value, yung 4.5 inches? 81 times 4.5 minus 36 times 4.5 squared plus 4 times 4.5 cube. So yung V natin dyan is magiging, so pag ginamit natin yung 4.5, magiging 0 yung volume natin, which is hindi po pwede. Therefore, hindi natin pwedeng i-consider itong 4.5. Ito yung i-consider nating x value. So ngayon meron tayong value ng volume. Ngayon i-verify lang natin if this box is really the maximum or the largest box na pwede nating makuha na volume. Ano, pag ginawa natin itong pagkat sa ating cardboard. Ano. So paano natin gagawin yun? Mag-second derivative test tayo. So gamitin natin yung first derivative natin. Ito. So ang second derivative natin ay so negative 72 plus 24x. So gamitin natin yung value ng x na 1.5. So negative 72 plus 24 times 1.5. Ang magiging value natin is negative 36. So since ang ating second derivative is less than 0. Therefore, maximum yung nakuha natin. Okay, so therefore, our final answer is 54 cubic inches. Okay, we have here example number 7. A rectangular field of a given area is to be fenced off along the bank of the river. If no fence is needed along the river, what is the shape of the rectangle requiring the least amount of fencing? Okay. So first step natin is identify natin yung given, yung unknown, and yung ating given condition. Well, in this case, hindi naman binigyan ng given value, pero meron daw given area. Meaning, meron tayong constant na area. So ngayon, binigyan tayo ng condition, ano daw yung, kung wala daw fence doon sa may river, kasi ganito siya, kung i-illustrate natin. So meron kang river dyan, ayan, may river ka dyan, And then, ito yung rectangular field na binabanggit. Mayroon given area dyan. Okay? So, kung hindi daw natin lalagyan ng fence, yung nandun sa river, ito lang ang meron. Ano daw yung shape ng rectangle wherein least amount of fencing yung magagawa. So, meron tayo ditong y, meron tayong y dimension and x. Sige. So, yung a is constant, pero yung x and y is hindi constant. So, a is equal to x times y, di ba? Since rectangle yan. So, isa pang pwede nating gamitin. So, nagko-construct na tayo ng equation na gagamitin natin for differentiation. Pero identify muna natin kung ano yung i-maximize or i-minimize nating quantity. But based on the problem, least amount of fencing ang binabanggit. Meaning, length of fencing ang i-maximize or i-minimize natin. Ano? So, kailangan natin kumuha ng equation for fencing. So, sabihin natin, ito yung L, length ng fencing na magagamit natin. Since ang lalagyan lang natin ng backward is itong may y, itong x, saka isa pang y, therefore, ito ay 2y plus x. Yan lang ang length ng fencing natin. Well, yan yung i-minimize natin kasi least amount daw. Minimize yan. Ano? So, syempre, as usual, dapat ang ating equation is naka-uniform yung variable, meaning isa lang dapat ang variable. So, dalawa yan, x and y. Y and x. So, meron pa tayo isang equation. So, paano pwede natin gawin? Sabihin natin yan ng x is equal to a over y. Yan. So, substitute natin dito sa ating equation ng length ng fencing. 2y plus a over y. Length of fencing. LF na lang ilalagay ko para hindi mahaba masyado. So as you can see, y na lang yung variable sa ating equation. Ngayon, pwede na tayo mag-proceed sa ating differentiation. In terms of y is equal to 2. So 1 na lang yan dahil y in terms of y naman yung diniderivative natin. Plus, ito ay u saka itong v. Don't forget that a is constant. Kahit ano pa value ng x and y natin, constant ng a. Basta yun yung value ng a natin. So, yung u natin, ay yung b natin is y times 0 minus a times y. The derivative ng y is 1. Don't forget the denominator y squared. Okay. So, cancel na yan. 0 yan. Equal to 2 minus a over y squared. So, ngayon, minimum ang hinahanap natin, equate natin siya sa 0. So, now, simplify lang natin yung nakuha natin after differentiation. You will have a 2 is equal to a over y squared. Cross multiply, you will have 2y squared is equal to a. Sige, as is lang natin yan. Yan yung equation natin, equation 1. So since doon sa may pinakauna natin, di ba meron tayong a is equal to xy? So yun yung isang equation natin. Equate natin yung equation 1 doon sa a is equal to xy. So therefore, xy, a is equal to xy is equal to 2y squared. So cancel out. You will have a 1 na lang sa baba, ay sa taas. X is equal to 2y. Or pwede nating i-rewrite yan into y is equal to x over 2. Therefore, ang ating shape ng rectangle, ang length niya is twice ng y. Meaning, kapag pinag-add mo yung nasa gilid, yun yung length ng x. Or, yung length ng isang y is kalahati ng x. Okay, so yun yung final answer natin. Di ba pag pinapahanap sa atin yung shape ng rectangle, gaya ng mga previous problems natin, always yung dimension yung final answer natin. Therefore, ito yung final answer natin for example number 7. X is equal to twice noong width, and then yung width is half of the length. For our last problem, we have here a closed cylindrical tank is to be made with a fixed volume. Fixed volume meaning constant ang ating volume. So lagay natin. Find the relative dimensions of the tank that will require the least amount of material in making it. Okay, so ano ba yung mga possible dimension ng ating cylindrical tank, ano? So meron yung dimension ng h or height niya, di ba? So hinahanap yan. Meron ding radius. Hinahanap din natin yung radius. Ayan. So find the relative dimensions daw. Tapos, least amount of material in making it. So cylindrical tank, hollow sa loob, meaning ang material lang na kailangan natin is para doon sa outer shell niya, no? Doon sa cover lang niya. Meaning, kung i-drawing natin siya, meron pa ditong tank, ayan, cylinder siya. So, ang kailangan nating isolve is yung surface area niya, total surface area. So, i-ano natin, nilagyan lang natin ang label, tong volume is constant. So, total surface area ng isang cylinder is equal sa 2, dalawang area dalawang area, ito yung area na isa, tapos itong area sa baba, plus yung area ng katawan. Itong part na to, yung nasa labas. Paano makuha yun? R, pi r or 2 pi r times h. So, nasan yung h? Ito yung ating h. Ayan. So, yung radius natin is nandito. Ayan. So, ngayon, ano na pwedeng natin gawin? So as you can see, meron tayong R, meron tayong H. So yung R, hindi yan constant. Pwedeng magbago yan. Yung H, hindi rin constant yan. Pwede rin magbago. So yung 2A na to, edit lang natin. Yung A natin is pi R squared yan. Hindi ba? Nire-write ko lang. 2 pi R H. So ngayon, hindi pa uniform yung ating variable dito sa ating equation ng total surface area ng isang cylinder. Therefore, kailangan pa natin ng isang equation. So sabi dito, constant yung volume, hindi ba? So pag volume ng isang cylinder, yan ay pi r squared times height. Okay, so kahit ano naman gusto natin na gamitin, yung r ba o h? H na lang, ano, para divide na lang kabod, hindi na may squared. Tapos mag-i-square root pa tayo. So divide both sides by pi r squared. You will have h is equal to v over pi r squared. Okay, so may h ka na. Balik tayo sa formula, sa equation ng TSA. So TSA is equal to 2 pi r squared. Walang h yan. Dito tayo magsa-substitute. 2 pi r times v over pi r squared. So as you can see, may pi sa taas, may pi sa baba. May r din, bawasan natin ng r yung nasa baba. So simplifying, we will have TSA 2 pi r squared plus 2v over r. So actually, pwede nating i-factor out yung 2 sa ating given equation. Ano, pwede naman din. Pero kahit hindi na rin, para mas simple lang din yung sana yung equation. Pero hindi na lang natin gagawin. Well, anyway, ang gawin natin dito is mag-differentiate na tayo. So pinapakuha yung least amount ng materials na gagamitin, which is ang i-minimize natin is yung ating total surface area. The derivative of TSA in terms of R is equal to 2 pi. Derivative ng R squared is 2R plus 2. Tapos derivative natin yung V over R. Pero yung V kasi is constant na yan. So yung 2V over R, differentiate natin yan. So yan ay R times derivative ng 2V is 0 dahil constant yan, minus 2V times 1 dahil derivative of R in terms of R is just equal to 1 over R squared. So cancel out yan, 0. So 2 pi R or 4 pi R plus or minus kasi negative 2V. 2V over R squared. Since pinapakuha yung minimum, i-equate na natin agad sa 0. The next step is ilipat natin yung 2V over R squared sa kabila. Kakaroon ka ng 4 pi R. Cross multiply, you will have 2V is equal to 4 pi R cubed. So divide both sides by 2. Ito, divide both sides by 2. Magkakaroon tayo ng V is equal to 2 pi R cubed. So meron tayo equation 1. So kanina meron tayong nagamit na volume din, volume ng ating cylindrical tank. So ito yung V is equal to pi r squared times H. So pwede natin equate yung nakuha nating 2 pi r cubed after the differentiation doon. So V is equal to V, therefore pi r squared times height is equal to 2 pi r cubed. So may pi ka sa left and right, cancel. May r ka left and right, pero may matitira sa right na r na isa. Therefore, H is equal to 2R. So therefore, ito na yung relative dimension ng ating tank wherein makakagamit tayo ng least amount of materials sa paggawa ng tangke na mismo. So kung yung final answer, pwede natin gawin is in text, naka-text. Therefore, the height shall be twice the radius of the base. Okay. So yung final answer natin is ito. Tapos kasama yung isang naka-box, yung h is equal to 2r. Ganun natin i-final answer. Or sir, paano pag ang final answer ko is r is equal to h over 2? Acceptable din naman. So sasabihin mo lang, the radius shall be the half of the height of the cylindrical tank. So pwede naman ganun. As long as parehas lang naman sila ng pinanggalingan na quantity. So I hope clear ang ating optimization problems na topic. So actually, medyo hindi siya ganun kadali. So you have to practice yung pagsosolve ng problems dito. Ito ay application ng differentiation. Therefore, uh, pinagsama-sama na concept ito from basic math hanggang sa calculus. So mahalaga na ma-practice nyo to and at the same time, kabisado nyo yung formula sa mga shapes, especially solids and 2D shapes para ma-solve mo yung problems natin. So if you have questions and clarification in our module 11, feel free to raise it sa ating group chat. So thank you for watching and thank you for listening to our lecture video for today.